So let's begin with a question on that uses sine and cosines. So we have already seen some simple questions using sine and cosine. This is slightly complicated and from a previous exam. So let's say f of x is given as so this is what the question tells us, that f of x is equal to sine of square root of pi square upon 16 minus x square. We need to figure out what's the domain of this function. So we know domain of sine is all the whole real axis. So sine does not impose any restriction on this, but x actually lies inside the square root. So the square root function, and we know argument of the square root function has to be greater than or equal to 0. So we just apply that equation, that condition. So we have pi square over 16 minus x square is greater than or equal to 0, or pi square over 16 is greater than or equal to x square. This implies x belongs to and if x is between minus pi by 4 and pi by 4, then the argument is positive and sine does not impose any restrictions on that. So domain of this function is given by now let's say we want to find out the range of this function. So finding out the range is slightly non-trivial and would require you to know some properties of differentiation and monotonic functions. So for those who want to try out, please do try the range of this function. One trick that I can tell you is take the derivative of this function and see if this function is monotonic or not. And then there is this, if a function is monotonic, that means it's either increasing or it's decreasing. So in that case, you just take the value at the start and the ending location of the domain. So you find out the value of the function here and find out the value of function here, and based on that figure out the range of the function. So this is definitely an interesting problem to figure out the range. So please try. And this requires some concepts from differentiation of a function. So you might want to wait till then in case you don't know these concepts. But we saw like a very interesting examples even with the domain, where we had to use not only the property of sine but also property of the square root function. And here you would see two functions are sort of related. So the output of this expression goes to the square root function, which is output of that goes to sine function, and this is essentially referred to as composition of function. And we will see more about composition of function and how can you figure out the domain and range of composition of functions in a principled way. So we will go there, but before that, let's take another example using sine and cosine. So for those who remember trigonometry, you might also remember, like, since we have sine and cosine, we also have you might also remember tan function, so which is tan of theta in the triangle and in the circle that we have drawn is given by y over x. So one thing to remember is sine of theta, tan of theta is given as sine of theta over cos of theta. So in order to figure out, so now we know this function, perhaps you also know the graph of these functions. So for let me also draw the graph of sine and cosine. So for sine function, you might again you might know this from before, is And cosine, the plot of cosine, I would recommend you to draw it on your own. And in case you don't know how to draw it, just remember you can use this tool and try to think of like rotating a nail along the circumference of the circle. So essentially, the cosine is given by this. I hope I'm drawing it correctly. Yeah. And these also extend to this direction. So try drawing the plots of these functions on the negative axis as well. So for sine, simply similarly you can draw it for cosine. So sine is given by blue and cosine is given by pink. So now you know sine and cosine and how they vary, and we also saw some like one complicated example to figure out domain and range of a function which involved sines. Now tan is again a function which is given by division of two functions, like by dividing one function by the other. And in this cases we need to use algebra of functions. So like we have algebra of like numbers, where like we add, subtract, divide, multiply numbers, same thing can be done with functions, and that is exactly what is happening here. Sine is being divided by cosine to get another function called tan. And in order to figure out the domain of tan function, essentially we will use the domain of sine and cosine and some rules of algebra of functions, which are fairly intuitive rules to figure out the domain of tan of x, or tan of theta in this case. So in this case the domain is given as, so you should pause the video in case you want to figure out what the domain is, but we will use two simple rules. So if you want to see how to figure out domain of division of functions and also of this important function tan, we see like when a function is being divided by the other, both of the functions should be divided, both of the functions should exist if for this function to exist. So let's say for some values the numerator exists and the denominator does not exist, then that point cannot be in the domain of the resulting function. So both sine theta and cosine theta should be defined. And in this case there are no exceptions because of this, because both for sine and cosine the range is the whole real line. So this does not impose any restrictions on the domain of theta. But since cosine is in denominator, it cannot be 0. So domain of tan is the whole real line except for the points where theta cos of theta is 0. And you can figure this out from the graph or from the stool, or if you know how cosine behaves. And then therefore the domain is given as the whole real line minus all the points of the form pi by 2 plus k pi. So here we saw, using simple principles that we have seen so far, what sine is, what cosine is. We've solved a slightly complicated problem from a previous exam, and also tried to figure out what the domain of tan is. And since you can figure out domain in this fashion, also try to figure out the range, and also try to plot the plot of tan of x. So that would be an interesting exercise. So next we will look into some other interesting problems and some useful concepts which we have seen so far interspersed, but we'll try to define them and understand